Hello and welcome to another Reigate Maths video. In this video we're going to be looking at the graphs topic from the first year Decision 1 unit from the A-Level Further Maths content. My name is Simon and in this video we're going to be focusing on the matrix layout for networks and graphs. If you haven't yet watched the introduction to graphs video or the graph theory video, I would strongly advise you do that first, because there's going to be some terminology that we're going to be using in this video that's introduced there. So matrices for graphs are a little bit different from what you may have seen already, either in your advanced GCSE units or potentially in the core pure of the further maths. The layout is going to be similar, but we're more thinking about the matrix as an array to describe information, not necessarily as something that we multiply together and that kind of thing. So a lot of the operations that you will have looked at in the core pure unit, we're not going to worry about here. There are two types of matrix that we need to worry about. An adjacency matrix, which just tells you the number of arcs joining any pair of vertices, and a distance matrix, which is a matrix which gives the weights of the arcs joining two pairs of vertices together. The way we use these and the way we fill in, particularly when two vertices are not directly connected, is quite relevant. The other thing with a distance matrix is this is different to a matrix of shortest distances, which is something that we will use later on in further videos, but it's still got the same ideas. The distance matrix that we're going to look in this video is just referring to two vertices that are joined together directly. So we're going to jump straight in with some examples and show you what's going on. So here we've got a graph, so we're going to be displaying this with an adjacency matrix. So we're going to have to list the vertices and along the top. And then effectively we're going to fill in this grid. Now if there is direction here, so this is not a directed graph, but if it is, then you have from and to. But typically the matrix, if it's given to you, will make that really, really clear. So an adjacency matrix tells us the number of vertices, the number of arcs joining any pair of vertices. So we have the pair of vertices A to A. Well, there are no arcs that join A to A, so 0. A to B, we have one arc, two arcs joining A to B. So A to B is 2. A to C, there's only 1. And A to D, likewise, there's only 1. B to D, there are no arcs that directly connect B to D. So we're going to put a 0 in there. There are no arcs connecting B to B. And there's one arc connecting B to C. Now we get to the interesting one, this vertex C here. So we've got this loop. So we have one arc that connects C to C in this direction, and one arc that connects C to C in this direction. So we in fact have two that we put in this element here. This is a weird one with this loop, which is why it's kind of a little strange and uncommon, but can happen. And then C to D, we've only got one. And finally, D to D, there are no arcs joining D to D. Now, if you really don't like having the letters next to each other or next to numbers, you can do this. But generally, you don't need to. Now, quite often in an exam, they will give you a grid in which to fill in. But if they don't, you can just do it like this example here. In this next example, we're going to look at a network as opposed to a graph, and therefore our matrix is going to be a matrix of distances as opposed to an adjacency matrix. We can still do an adjacency matrix on a network, but we tend not to. The way we input no connections is slightly different from the previous example. So M to M, there are no arcs that connect M to M. So there is no distance. So we put a dash instead of a 0. If we put a 0, that implies that there is a arc, but the weight of that arc is 0. So you've got to be careful with a distance matrix. The other difference is M to B, there's one arc, but we know the weight of it. So instead of writing 1, we actually put the weight in our matrix. And we continue. M to L is 126. M to E is 244. And M to N is 283. And this is what your finished matrix should look like. You can see there's lots of dashes because there's lots of vertices that don't have a direct connection. Now, quite often, the algorithms that you're going to look at that use networks or use matrices, we will instead use the matrix of shortest distances. So for this B to E element, instead of there being a dash, it might be 82 plus 148. That total would go in there to show that although there's no direct connection, that's the shortest distance between the two. And that will allow us to do the algorithms that we need to on this network. The other thing to pay attention to is if there's direction on these networks. For instance, if we had that, so E to M has a length of 244, E to M would be 244, but M to E has no direction, so we put a dash there instead. So you do need to be careful if there is a arrow or direction shown on your graph.